This is the students' workshop. Inside you'll find all sorts of machines, and in this lab we will use the milling machine, the table press drilling machine, and the lathe machine. But before we start, please follow the health and safety information guide. You must leave all your belongings in the locker provided and wear eye protection, the goggle, and if you are doing welding, you must wear the face mask and the glove. To start this lathe machine, first use the chuck key to tighten the workpiece, and make sure the chuck key is not left on top of the chuck or in this square key, so that when the chuck runs, it wouldn't fly out from the chuck. Then cover this chuck guard like so, and then lift up the safety button by twisting it. You lift up like so, you twist it, you lift up, and then press this green button to turn it on. So once it's on, there's a green light. Notice if you take off the chuck guard, the green light would disappear, and you have to reactivate it again once the chuck guard is on. To turn it, there's this control to turn it. To start it, first for clockwise, push up, and the chuck will turn clockwise. To stop it, push it to the middle position, and for anti-clockwise, push down. Push down. Yes. And it turns. Again, to stop it, put it in the middle position. So how do you move the carriage? You can move the carriage by turning this. For X position. For final adjustment, you can turn here. It also advances it in X direction. For Z direction, you turn here. This is for Z direction. So you will experience this in the simulated lathe machine. Of course, the nuts here can be loosened, and you can change this two table into different angles. Notice the different angle over here to change the cut, which I will demonstrate later when I do the gear knob. So this is the tailstock. To lock it, you lift it up, and to unlock it, you push it down, and you can push this whole thing once it's unlocked. Very heavy. You can push this, and then you can lock it like so. And then to turn it again, turn it. So this tailstock is to do drilling. This is the milling machine. So to start the machine, you press this button and it starts. Stop, and here's the brake. This is the brake. This is to start the lubrication, and this is to start the work table to move from left to right. To turn the table left or right, you turn here. This is to turn the table left or right manually, or can do it automatically using this. Turn it start, press start, push left, you go left, push right, you go right. Push left, you go left, push right, you go right. And here's to control the speed. to move in Z-axis, front and back, you turn here, this handle, and to move it up or down, you turn this handle. Here's to turn it, move it up or down in Y-axis. So Z, Y, and X. Separately, you can also move the drill width. You can move the tool up or down using this handle, but it's a bit harder. It's much more easier to move the workpiece than the tool. And you can set the speed over here. This is the milling machine. These are the material supply for this lab. This steel block is to make the gear knob. This steel rod is to make the gear stick. And this block is to make the gear base. So the gear will look something like this, with the knob on top. First, we start by clamping the workpiece. I'm going to make the gear knob first. You have to clamp the workpiece onto the chuck. How to clamp the workpiece onto the chuck? How far does it go? So the common guide is to leave at least 3 cm thereabout to be clamped onto the chuck. So to clamp it, just put the chuck key in, twist, and turn itself. Of course, when you turn, always shake about so to make sure that it center itself correctly. It's center, and then you have to tighten it with both hands. Once it clamps, you can test whether your workpiece is being clamped centered or not. First, you start it first. Let's start it. Turn it into a slower speed. In this case, I'm using certain speed. I'm not going to tell you. You're going to check, guess it yourself. Then I'm going to just rotate to see whether it's centered. So it should not wobble. If you can see, it should not wobble. If it's wobbling, then it's not centered. So what happens when it wobbles? You can re-tighten it again, or you can insert the workpiece deeper into the chuck to be clamped. So in my case, it's not wobbly. Okay, I'm testing it again for higher speed. Always remember to press this green button or else it wouldn't start. So is it wobbly? A bit, seems like a bit. So I should try it again. Another way to fix the wobbly workpiece is that you can loosen it slightly. With the chuck key, you loosen it slightly. And then you gently tap it with mallet. Tap it. To insert it a bit. Then only you fully tighten the chuck key. And now I'm going to show you how to do turning. First, you must fix the appropriate tool onto this tool holder. So for turning, I'm going to use this. This is for turning. So just simply insert it into this tool holder. And then you tighten it with another square key. This key. So you tighten all 3. I'll come back again when it's done. Of course, to make sure that it is very tight, you can hit it with a mallet. Of course, you do it with both hands, please. So once you have the appropriate cutting tool, then you can advance the entire carriage to your workpiece by turning this spindle. Okay, not too close because you can use this finer adjustment. Okay, maybe a little bit more. Okay. Turn this spindle for finer adjustments. Because if you notice, the division, one division is 0.05 mm, while the other one division is 0.5 mm. So you can see the sensitivity of each spindle. Okay, first setting datum. This is to determine the position of your workpiece relative to this carriage. So to do so, I suggest you trim a little bit of the previously old materials so that it's cleaner. Let's start by doing that. Okay. So it just touches the edge of the cylinder. So I'm going to set this as the Y datum. So if you notice there's this wheel over here, you can set it as 0. So you turn the key, the thumb. You can turn this thumb screw. You just set it as 0 and then tighten the thumb screw. So this is your 0 for Y. Now let's set 0 for X. I'm going to start by cleaning off the rusty surface, then only I set it as 0. Another more. So now when the surface is cleaned thoroughly, I'm going to set this position as 0. So again, here, over here, find the thumb screw, loosen it, turn it to 0. Turn it to 0. Tighten the thumb screw. So this is your 0 for X and Y. Now I'm going to show you how do you trim. So to trim X, you just advance the X over here. So when you trim, it is good that you trim 0.5 mm per time, because if you feed it too much, it's going to wear the tool head and it's going to heat up the workpiece a lot. So if you want, you can turn on the lubricant fluid, but in this case I'm not going to use that because I'm not going to advance it so much per time. Okay, let's trim a bit. Let me show you how to trim. First, you advance 0.5. Make sure it's out of the way first, out of the workpiece. Then you slowly increase the Y. You gently increase the Y. You're going to get trim off real soon. It is always good that you move the tool, the cutting tool, out of the workpiece before you stop the machine. So previously, my cutting tool was here when I finished the cut. So before I stop the machine, I would move the tool away from the workpiece before I stop. If you notice, the surface of the cut is very rough because I use a very slow turning speed. So to finish it off for better surface finishing, I'm going to increase the speed of the turn and see what happens. Of course, always remember to press the green button before you start. There, the surface is much smoother. Of course, the cutting tool head also affects the surface of the workpiece, the final finish. And in this case, the workpiece, for this workpiece, my cutting tool is a bit worn. As you can see here, it's a bit worn. So I wouldn't be getting a very good surface finishing in this case. But if you have a very new cutting tool, then the surface would be much more smoother than this. So it's not advisable that you cut with a very high speed. You only use high speed when you want to finish it off for the final surface, because if you cut too fast, you will have excess heat and you wear out the tool very easily. So I want to select a lower speed now. I'm in a certain speed and I'm going to change it to a lower speed. Okay. So if you notice, I'm trying to crank it up to a Q. I cannot, it gets stuck because the chuck is a bit stuck. So I must push the chuck a bit, turn the chuck a bit, then only I can lock it to Q. So you might want to do in both hands simultaneously, where one hand you turn the chuck and another hand you turn this control wheel, which I'm going to do now. Okay, now it's in Q, which is the slower speed. Okay, next, after you know how to do cutting, I'm going to show you how to cut in a lateral X position. Again, if you cannot turn on the green button like me just now, your control here might not be in the center position. Always make sure it's in center before you press the green button. There you go, you can press it now. Okay, let's cut in X direction. Let's start. Slower speed, of course. Then you gently advance Y. Okay, notice where is the datum. It's a 0, so you advance 0.5 mm only, and then you cut inwards. Okay, when I want to stop, always move the cutting tool away from the workpiece, then you stop the machine. Okay, lift it up, the cover, then it'll turn off automatically. So I'm not going to cut it all, just for demonstration purpose. I'm just going to cut here, but you can see certain parts are being cut. You see silver color, and certain part, you see there's still rust. So what does it mean? Can you please discuss it in your lab report? Why certain part is cut, while the other part you can see on the other side. Let me turn this spindle around. On the other side, it is still rusty. Why? Why is it so? Can you tell me in your lab report? So it seems like I have to cut it a little bit more deeper. So I'm going to advance to 1 mm. Always workpiece and the tool are not in contact, then only you start. So it's better now. Everything is clean. Yep. So all parts are clean. So I'm going to advance it to higher speed to finish it off. S. Okay, don't forget this. See, much more smoother surface. Again, when you're at higher speed, always watch out for your feed rate, because higher feed rate will cause tool wear and excessive heat. Notice that after you turn, there is sharp edges over here. So there are two ways for you to smoothen it out. First, you can use a file like this, or you can do tapering. And in this case, let me show you how to file this. Guards on. There's the green button. Turn it to a slower speed. I use, okay, you guess, around 100. Turn it. Let's turn it. And then I can just put a file here and just file it to smoothen the sharp edges. Of course, you must use it with both hands. In my case, I have to use one hand only. Next, I'm going to teach you how to do taping, which is angle cutting. First, you must spin this entire work table into the degree that you want. So in this case, I'm probably going to use 30 degree. So let's loosen these 4 nuts over here, and then I'll come back again. Don't be surprised if you find the nut is too tight. You probably have to hit it with a mallet. So once the nuts are loosened, you can spin this cutting table to the degree that you want. So I'm going to choose, let's say 30. And then I'll tighten the nut again. So plan your cutting path by adjusting the X and the Y. So you plan before you cut. So in my case, I probably need to advance this Y, more Y. And then I'm going to cut like this to the left. See? Okay, let's start. Check the speed. Always check the speed. Are you at the right speed? Yes. Okay, once you are done with tapering, you get a cut of 30 degrees. So you're free to design whichever shape that you like that can be lathed. Next, I'm going to show you how to do drilling with lathe machine so that you can insert your gear stick into the gear knob. To do that, first you must move this carriage out of the way so that you can use this tailstock. So first, by spinning the y-axis back away from the tailstock. Okay, once it's out of its way, you can unlock the tailstock and push it over to the spindle. So before you drill a hole into your workpiece, you always have to center the drill first. This is to make a hole to guide this drill bit into your workpiece. Because without this center drill, when this drill bit enters the workpiece, it will wobble. And then it will create a bigger hole than you want to. So you push your tailstock all over here, closer to the workpiece. And then you lock the tailstock. Fix this center drill, turn it on, and turn. And then just drill a little hole so that it serves as a guide for your drill bit. Okay, once you get a little hole, then you can proceed to the full drill. So next you can fix your drill bit, then you're going to drill into the hole. So if you notice on this tailstock there is a scale. So let's say I want to start with 1 or thereabout. I just push the tailstock forward and then I can tighten the lock, tighten both lock, then I turn into, let's say I want to set 2 as datum, so I turn into 2. Okay, so that's my 2 datum. So I lock this tailstock. Okay, this has to be kept open because this controls the drill bit, so this is kept open and you just reverse it back a bit to start the machine. Press green as usual, start, and then just turn the tailstock forward gently, Now perhaps it will be a good idea to turn on the water because it's very hot. Turn on the water. So this lubricant will keep the workpiece cool while you drill. And here is your finished lower part of the gear knob. Before you take it out, always remember that after you do turning or drilling, the workpiece will get quite hot, if not very hot, until it burns your hands. So always give it some time to cool, like 2 to 3 minutes at least, especially if you don't use the lubricant, then it might get much hotter. So what happened to the upper part? The upper part is up for you to design. You can lathe it, turn it until the end, or you can trim it with the saw. Then only you finish it, the upper part of the gear knob. So you can do chamfering, tapering, curling, all sorts of different design onto the upper part of the gear knob. So to fix the gear stick onto the gear knob, we would use a screw method. So we would have to do internal threading on here and external threading on here. For this hole, I have drilled it to be 8 mm only, And here I'm going to trim this down to 9.3 mm so that we can do threading later. Right, I have laid the gear stick to 9.2 mm, and I'm going to do external threading on this one and internal threading on the gear knob. So you use this external thread tool and you turn it around until it makes a thread at your gear stick. So before you do that, always give ample amount of oil and then just turn it clockwise. So you cut a groove into your metals that you've laid. For every half turn you do, it's recommended that you turn back half a circle to get rid of the metal chip that you chip off. So you turn, give it a bit of backward motion before you advance it again to remove the chip off the thread. So once you have completed the turn until the end of the thread, you will review your full thread. This is your threaded part. For the external thread in gear knob, you can tighten it over a clamp at the workbench. Then you use these, the threading tools. There are 3 stages to do in threading. First one, you start with the lighter thread, which is number 1. Then you move on to number 2 and number 3. This will make the thread cut gradually instead of suddenly, because we are cutting metal with steel here. So you notice the depth of the cut are different for each number. So you start with shallower cut until you get a deeper cut. So just fix this over to here, the holder, and then I'll come back again when it's fixed. When you are doing external threading, always make sure that it is perpendicular to the workpiece, or else your thread would be bent. And again, follow the advice as I gave previously. For every single turn, make half backward turn. This is to remove the chip from the thread. Then you can test the thread that you've made by screwing the gear knob on top of the gear stick. It should work. Milling machine can do face milling, can do drilling, depending on the attachment that you do on the tool. So for this case, I'm going to make a hole inside this block, in the middle of this block, to attach the gear stick on top of it. At the measuring table, I'm going to measure the height and the width of the block, and then I'm going to find out where is the center point for me to do the center drill hole. After the center is being found, use this to tap a hole indentation into the workpiece so that your drill bit can commence drilling. Simpler tasks like drilling a hole, we can actually use this table drill. To start drilling, first you have to turn on the switch and then lift up the cover to reveal the on button. Press on. And you can move the drill bit by turning this wheel up or down. Let's stop for a while. First, move it down so that to make sure it is aligned properly to the hole that you made. So this is not, so you have to fix it properly. Make sure it is aligned. Good. And then you can start drilling. In this case, I need to be careful not to move too much. So you press down to drill. So you can look at how the depth of your drill by the indicator here. Keep pressing. But do bear in mind that the drill bit may overheat. Give it a break sometime and continue drilling. You may add water to increase the drill efficiency as well. But try to go slow on this. So after you have drilled the hole, your gear stick should insert it perfectly into the hole and ready for welding. So this is the gear stick that I've made as a sample. Of course, you can change the gear knob design as you wish, as long as it can be lathe. However, the threading and the welding to the base are fixed, so you must include these two components in your report. Please look at part 2 on the E-Lab instructions on welding. Thank you.